Hello. This is the notes day that goes with the first assignment in Unit 1, which is our review of algebra unit. The worksheet that these notes coincide with is the Algebra 1 worksheet here, the first one. Notice that there is an answer bank at the bottom. The answer bank is for the entire worksheet, front and back side. I don't necessarily recommend that you squeeze your solving into the worksheet. It just gets really difficult to read and people tend to make mistakes. But it would be a good idea if you have the ability to print out the worksheet, do the work on your own paper, and then utilize the answer bank to check your work. Just highlight the ones as you go. So some of these questions are really easy solving, like the ones in the beginning. And just to remind you of good solving form. There are some things that you do when you solve that just work out better in the long run. They're more flexible and there are less mistakes. One of them is remembering that you have to do the same thing on both sides of the equation. So for example, if you have a 3/4 y equals 1/2, to get y by itself, you need to get rid of the 3/4. To get rid of a scalar from a number, you always want to think reciprocal. And that's because as we get into more difficult solving, there will be more fractions that you have to deal with. So to get 3/4 to cancel out, I'm going to multiply by 4/3, which is its reciprocal. If you do that on the left, you are required to do it on the right. So any number multiplied by its reciprocal is 1, and that's why it works. So 4 divides into 4 one time, 3 divides into 3 one time, and so you really have a 1 times 1 times y, which is just y. On the right-hand side, you're going to multiply tops and tops, bottoms and bottoms. Now, one thing you might notice looking ahead is 4 is an even number, and I have a 2 down here. So sometimes instead of multiplying it out, it's actually faster if you just prime factor it as is. Well, 1 is a placeholder. 4 factors into 2 times 2. On the bottom, I have a 2 times 3. If you prime factor it, you can save yourself some long division. 2 divides into 2 one time, and you're left with y equals 2/3. And always put a box or a circle on your answers and skip a line. So I wanted to show you that one. Let me give you another one. Example 2. 1/3 x equals 2x over 5 minus 1 over 5. All right, so the rule about reciprocals works even if there are more than one term on the right-hand side of the equation. So to get this x alone, I have the option of multiplying by the reciprocal of 1/3, which is 3 over 1. Now, if you do that, you have to multiply the entire right side by 3 over 1. So it actually gets distributed. And again, you have different options for solving, but I want to show you some of the good habits that we picked up in Algebra 2. So 3 divides into 3 one time. X is alone. And here we're going to go tops times tops, bottoms times bottoms. So 2x times 3 is 6x on the top. 5 times 1 is 5 on the bottom. Now this one, 3 times a -1 is a -3 on the bottom. 5 times 1 is 5. So that's how you multiply by the reciprocal with two terms. Now if you want to get rid of the fractions, you can just deal with them as is, or you can get rid of them. Most people prefer to get rid of them. So to clear the fractions, you need to make all of the denominators match. Well, these are both already 5s, so the x term needs to have a 5 on the bottom. So if I multiply the bottom by 5, so they match, I have to multiply the top by 5 as well. Now that all 3 are 5s, I can use the reciprocal, which is 5 over 1, and multiply all terms on both sides by 5 over 1. What happens is the 5s divide out, and all you're left with are the tops. 5x equals 6x minus 3, which is much easier to deal with. Subtract 6x from both sides. You get negative x equals negative 3. And of course, you multiply or divide both sides by a negative 1, doing the same to both sides, and you get x equals positive 3. Notice that my equal signs are lined up so that I'm not forgetting terms. Also see that I'm being very careful about the fractions to give them space so that I don't drop any terms. So that was kind of an interesting problem. Let's do example 3. 3a equals 1/3 pi times r plus p. And remember, semicolon just means directions. So we're going to solve for p. Okay, so the term we're trying to solve for is here. It is in a binomial, and that binomial is trapped because it's multiplied by 1/3 pi. So to get it out of that situation, you want to peel off this scalar right here. We want to get rid of that. So to get rid of this, I'm going to multiply the whole right side by its reciprocal, which is 3/pi. Of course, I have to do that on the left, multiply by 3/pi. On the right, the 3 divides out, the pi divides out. Now, we're not going to distribute because the pi over 3 was a scalar, so you multiply scalar to scalar. You only distribute if you have two terms that are not connected by a coefficient. They're just two separate terms. Then yeah, you got to distribute. This one, not so much. So on the left, we now have 9a over pi. On the right, we have r plus p. So to get p alone, we're going to subtract r from both sides. I do need to flip-flop so the p is on the left because that's what we're solving for. And we've got 9a over pi minus r. This is where you're going to look in the key in the answer bank to try to find it. If you don't find it with two pieces, you might have to convert it to a one piece in order to check your answer, which is really easy to do. You do exactly what we did here when we wanted to get the identical same denominator. We multiplied by what was missing over itself. We do that here. To put these two terms together, the r term needs pi. So I'm going to multiply by pi over pi. Now that they're both pi terms, I can put them together. 9a minus pi r all over a single pi. And you will know when you need to do this because the answer key will have one of those two. All right, so that was what I wanted to show you today, just to review some specific problem types that give people issues and to go over good solving habits. So good solving habits, think reciprocal. I would say good solving habits are line up your equal signs. Make sure that you use good brackets and parentheses when necessary so that your algebra brain can process what it is you want to do. All right, that is the end of the notes. I hope they were good. Talk to you later.